Okay, in this lecture, we're going to go over uniform probability distributions. Uniform probability distributions are the simplest of all the distributions. And essentially what you're doing is just simple geometry and calculating the area of a rectangle. So what I have here is I created this graph with two axes. And so we've got 0 all the way to 65, and we're going to do this in just a minute. And then up here, we're going to do the axes for that in just a minute. So, oops, that's not what I wanted. What I've got here also is the formula sheet. If you go down to the bottom left-hand side, you'll see uniform distribution, and then you've got the standard deviation, the mean, and so on and so forth. So the area of all probability distributions, this is really important, the area of all probability distributions equals 1. So the area of our rectangle is going to equal 1. And so when we have a normal probability distribution, when we have a binomial, when we have any kind of probability distribution, the area will always equal 1, and it will account for all possible probabilities. And so what we've got here, the area equal 1, and we have the base times the height is going to equal 1. So we have to find the base and we have to find the height. So I've got an example. Now, a uniform probability distribution is really important. Basically, it means that the probability of any given outcome is going to be the same at each trial. So for instance, I have a Starbucks card. And on my Starbucks card, the way that I have it set up is if the balance ever drops below 10, it automatically loads $25 on my card. So area, or sorry, probability of any outcome is the same at every trial. Okay, and then also we have set minimum and maximum. And notice here, this gets really confusing between the binomial probability distribution and the uniform. So this right here is the uniform. The binomial is probability of an outcome is the same at every trial. So really big difference here. What we're looking at is the probability of one's very specific outcome, either a that success or the failure. The probability of that one particular outcome is the same at every single trial, where with uniform, the probability of any possible outcome is the same at every trial. And so with the uniform probability distribution, what I have here is I have that my card can be anywhere between $25 to $35. Okay, so I'm going to do that right there. So anywhere, between $10 to $35, it can be anything in here. And so I now know my base. Okay, the range of my base, so we're going to find range, is going to be max minus min. So we've got the max minus the min, and what is that? That is going to be 35 minus 10, and so the range is 25. Okay, and so now we have the base. So the range, we've got base equals the range, and so the base of 25, and now we need to calculate the height. Okay, and so the height is going to be 1 divided by 25. The reason why it's 1 over 25, very specifically, sorry, is because, yeah, that's not right. Hold on. Text 1 divided by 25. The reason why it's 1 over 25 is because whatever the base, remember, base times height equals 1. So if we know the base, which is 25, then the height, so we've got 25 multiplied by the height equals 1. So 25 multiplied by whatever this is going to give you 1. So that's going to be 1 over whatever the base is. And so what is equals 1 divided by 25. And that's going to be, it's not 0. Let's get the decimal. There we go, 0.04. So the height right here, we can just do 0.01, 0.02, 0.03, 0.04. Okay, so we've got the height right here, which is 0.04. So the probability of any one of these given outcomes is going to be 0.04. Now, more specifically, there is a 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, all the way up to 35. So the probability of any one of those given outcomes, and when I say 10, I'm saying 10 all the way up to $10.99. When I say 11, I'm saying 11 up to $11.99. So the probability of any one of those given outcomes is going to be 0.04. And so we have the base of 25 multiplied by the height, which equals 1. So if I say, what's the probability of you having $25 on your card? That's going to be 4%. What's the probability of you having $22? The probability of that is 4%. Now, the other question is because we're just doing base times height, we're going to keep on doing the base times the height. So now we know base equals 25. Okay, height equals 0.04. And so 25 multiplied by 0.04 equals 1. Okay, now what if I want to know what is the probability of a particular range? Okay, so if I want to know what's the probability of me having between $25 to $35, well, what did I do? I just changed the range, or I just changed the base. Now the height is staying the same, okay, because the every single possible outcome is between 10 to 35. But I want to know, of all these possible outcomes, what's the probability of you having a snippet from that possible outcome? So I've got the new base, which is 20, I think I said $25 to $35. So now we've got 10 multiplied by 0.04. So let's do that. Equals 10 multiplied by 0.04, and the probability is 40%. And so that's 25 to $35. What is the probability of having between $25 to $35? And that's going to be 40%. What's the probability of having 20 or more? Okay, well, the max that it can be is 35. So 20 or more. So what we do for that is 35 minus 20 equals 35 minus 20, and that's going to give us 15. So we're like, okay, there's a range of 15, so equals 15 multiplied by 0.04, and that's going to give you 60%. Okay, and if you have issues with not being able to see everything, you can you can do this a little bit and then just increase the decimals. But 0.6, so 60%. I'll do so 20. So the range is 10. And then if I were to say 15 or less, then I would be 15 minus 10. 15 minus 10. So then it would be the range multiplied by the height, which would be 0.04, and that gives us 20%. So all that you're doing is you're calculating what is the area of this rectangle. And so 15 or less is what is the area of this rectangle. 20 or more is what is the area of this rectangle. 25 to 35 is what is the area of this rectangle. And so you just keep on changing the area and calculating the new area. And so the height always stays the same. And now that you know the set minimum and maximum, you can check to see, okay, what is the the range, or what is the area based on a specific range. So you've got a set minimum and maximum. The probability of any outcome is exactly the same at any trial. There's not necessarily a set number of trials. And technically it can be done with continuous or discrete. But really it's better with continuous. Works a lot better. There's a lot of things that you can do with this. But this is pretty much what we're going to do in this class, is find the base, or find the range, and multiply it by the set height. And that will give you the probability of a specific outcome in relation to any possible outcome.